Hi everybody. Today we're going to take a look at percent composition. We're going to take a look at percent composition in the context of minerals, where we can figure out the amount of a metal in an entire compound, or later we're going to take a look at it in the context of organic compounds. So here I have three different copper minerals, and they each have a different amount of copper as a percent of the whole. Let's take a look at how we calculate these. So here I have hematite and magnetite, some iron-containing ores. And we would want to know if we have the exact same amount of both, maybe 100 tons, which one would give us more iron? And percent composition allows us to do that. So you can see I have the equation written at the top. It's the mass of whatever we're interested per mole over the molar mass. So let's take a look at how we solve these problems. You can see I've set up the problem for the percent iron in hematite. So let's walk through it. I have the molar mass of iron multiplied by 2, because there's 2 irons, over the molar mass of the entire compound. Simplify those, multiply it by 100 so that it looks like a percent, and we end up with just under 70% iron in hematite. I'm going to have you try magnetite, so pause the recording and try it. When you're done, hit play again. Okay, are you ready to see your answers compared to mine? I took the 3 irons and again found the molar mass. Simplify, multiply by 100, and there's slightly more iron as a matter of mass percent in the magnetite. So if I have 1,000 tons of each, I'm going to get a little more iron from the magnetite. That's which one you would mine. Now, keep in mind that there's a lot of other factors involved. Accessibility, amount of processing, and all those others. But for now, we're just looking at the amount of iron in each mineral. Here's a third way of finding iron in nature: pyrite. It's called fool's gold because if you take a look at it, it's a gold color. It's a little more cubic than gold. So first, if we want to know the actual scientific name, FeS2, it would be iron 4 sulfide. Now that you know the formula, pause for a second and find the percent of iron in the pyrite. Okay, let's compare the answers. So this one is much lower. It's only about 46.6% iron in the pyrite. Now let's take it a step further. Ore is usually a mixture of rock and the mineral we care about. So let's say the ore is only about 28% pyrite. In these rocks, what's the percent of iron in these rocks? To solve that, we need the percent of a percent. So 28% of the 46.6%. So in this rock, only about 13% of that rock is made of iron. All the rest of it is other stuff that we don't really care about. So that's how we solve percent composition problems. There are several for you to practice in the homework. We're going to use percent composition as we look empirical formulas later.